Hey, geometry students, Mr. Davis here with just a slope review. I know we have a video on 3.5 that's already on Moodle, but we had a struggle on the 3B quiz. The scores weren't great, and in talking to some students, they felt that their background knowledge on slope maybe wasn't as strong as we've certainly seen it. And part of that is probably distance learning from the spring. You didn't get a full in-person Algebra 1 class. Slope is a big part of Algebra 1. And there are some things that we're going to have to figure out a way to make that work. But with slope, we really have to slow down, stop, and learn this a little bit better than we demonstrated on our first quiz. This also may be getting watched in the future. So I'm going to make some 2020, fall of 2020 references here that may not apply to you, but the content I'm hoping can be used in the future as well, just in case somebody is trying to do the second part of chapter 3 here and maybe doesn't have the greatest of backgrounds with the idea of slope. You'll see these words a lot: rise, run, and slope. We'll explain those here in a little bit. Here's the state standard that we're operating with. Parallel and perpendicular, need to have an understanding of those ideas as well. Here's a definition: slope is the steepness of a line. Sometimes we're working very visually. You get a picture and you're asked to find the slope. There was a question like this on the quiz. I had hoped we would do a little bit better on it. But when you're given the picture, all you have to do is count. When we're talking rise over run and we have the picture in front of us, pick 2 points. And again, those points don't have to be picked for you. You don't have to know where these points are. You can just go on the line and start counting. So you count, in this case, going from this point to that point, we end up going up 6 and over 4. Up 6 squares and over 4 squares. And therefore, the slope, as I move myself here, the slope then is 6 over 4, which can be simplified to 3 over 2. Now just think, the line goes through this point as well, this point here at 3, 4. Just think if we counted from here, we would count up 1, 2, 3, and over 2. So again, the thing about a slope of a line is that if the line is straight, the slope is consistent. If this line extends forever, which it does, we can continually count up 3 squares and over 2 squares all the way to infinity in both directions. We also have a slope formula, which we'll get into here shortly. That slope formula basically tells us to subtract the y values and subtract the x values. And that also gives us rise over run. Slope is typically a fraction. By the way, we don't want to simplify, or excuse me, we don't want to turn that fraction into an improper fraction. We don't need to turn this into 1.5 or even 1.5. Leave it as 3 over 2. Math teachers, in general, when we're talking with slope, we don't mind improper fractions. In fact, we prefer them to decimals and mixed numbers. Sometimes we're just given the points and we're not given a picture. So in this case, we have the point 3, 1 and the point 2, negative 1. Now we can plug in. Almost a better thing to do is just ask yourself, how far apart are these things? Well, from 1, let's go backwards. Let's go this direction right here. So from negative 1 up to positive 1 is a difference of 2. And from 2 to 3 is a difference of 1. So we have 2 over 1. Now you notice your book here wrote the formula out. They got an answer of negative 2 over negative 1. They both work because they both simplify to 2. So we will take the slope and change it to a whole number if everything works out that way. If the numerator, if you can take the denominator into the numerator an even amount of times, or if it divides in evenly. 4 basic types of slope are positive, negative, 0, and undefined. This picture appears in probably every math textbook from about 7th grade on up. So we have to understand that lines going this direction will always have a positive slope. Lines going this direction will always have a negative slope. A horizontal line is 0, and a vertical line is what we call undefined. The reason it's undefined is that we're dividing by 0. When we calculate the slope, the denominator of such a line is 0. Notice now, you may be asked a general question like this, but if you're asked specifically, what is the slope of this line, you have to give the numerical answer. You can't just say positive, negative, 0, or undefined. But this will help you know if your answer is right or not. If you do your calculations, your line's going this direction, and you get a negative value, you know that you made a mistake somewhere. And also to know is that slope and the words slope and rate of change. This is a little more of an Algebra 1 thing. I know in the typically on the 8th grade MCA test, there's a big emphasis on the fact that slope and rate of change are kind of interchangeable. Less used in high school, although we're going to see a word problem here where it does come into play. And speaking of that, here we go. So this does not appear to be a slope question, but it really is. And we could put this on a graph, which I believe you're going to see here shortly. I keep getting myself in the way here. I apologize for that. But you know, we're plotting Justin's travels here, and we're basically the bottom is the time of day, and this is the miles from home. So finding these 2 points, and obviously Justin was traveling at a constant speed here, but we can subtract and find the Justin's rate or his speed will equal the slope of this line. Notice now our units are different. We can't just count boxes here. If we count boxes, we're going to be wrong because every box on the horizontal axis is 1, every box on the vertical axis is 100. So we have to do the subtraction. Once we do the subtraction, we're going to use those points. Again, sorry if this is distracting with me kind of moving myself around here. But when we do this subtraction, we end up with 195 over 3, and we get 65. So Justin was traveling at 65 miles per hour. Hugely important theorems here. Slopes of parallel and perpendicular lines. I mean, you can't see the word lines there, but trust me, it's there. But parallel lines have the same slope. If the slopes are the same, the lines are parallel. If the slopes are opposite reciprocals, a key phrase here, opposite reciprocal. The definition says here the product is -1, but think opposite reciprocal for that. If that's true, then the lines will be perpendicular. I'm not going to read this to you. I'm trying to keep this video to a relatively short amount of time so people can watch it and potentially get ready to retake their quiz. By the way, there is a key phrase in here that needs to be repeated in order to do the retake if you're a distance learner this year. So let's get to that. You could be asked this question. There's a question similar to this on the quiz. So we got to calculate the slopes between these. We've actually drawn them out here. They sure look perpendicular, but let's find the slopes. And if we find the slopes, we see that yes, in fact, 3 and -1/3 are opposite reciprocals. Therefore, these lines will be perpendicular. We can't just say they're perpendicular because they look like it. We have to have proof. And one way to prove it is to calculate the slopes. And if the slopes are opposite reciprocals, then they are they are perpendicular. So in 2020, and again, this will be a little out of date if you're watching this in a different year, but the quiz 3B, in order to retake that, you must include the phrase rise over run in your email asking for the retake. That tells me that you watched the video. I suppose you could find this out and email that to me anyway, but I'm trusting you to watch this. It's about a little over 8 minutes long, so we're not asking a ton of time. And the information is pretty important. It's real tough to pass. Geometry, it's real tough to pass high school math classes if you don't have a good understanding of slope, or at least a better one than we demonstrated on the quiz that we took. So no problem if you had a bad quiz, that's okay. We just need to learn from it, and one thing we need to learn here is slope, and I'm hoping that this video can be of help. So that concludes our video. Remember the phrase if you're asking for a retake, and that concludes our video on our supplemental video on section 3.5, slopes of lines.